Hello, welcome everyone to this ContainerDays talk about policy as code in Kubernetes with Gatekeeper. My name is Pulido. That's my Twitter handler, so if you have any questions throughout the conference or after the conference, feel free to reach out. So we are going to be talking about embracing change, policy as code in Kubernetes with OPA and Gatekeeper. So being ContainerDays, obviously many of you already know what Kubernetes is, but just in case, Kubernetes is a containers orchestration platform to help you run containerized applications in production. It's super successful. It's an open source project powered with CNCF, so if you haven't, check it out. And this talk is not about Datadog itself, but just so you know that Datadog is a monitoring and analytics platform that helps companies improve the observability of their infra and applications, including, of course, Kubernetes as a platform, but also the applications that you run on top of it. But today we are going to be talking about policy. And when we talk about policy in software services, basically what we are talking about are rules that governs the behavior of a software service. So if you're talking about Kubernetes and rules that govern the behavior of a software service, this looks a lot like RBAC that we already know, we already use in Kubernetes. It's role-based access control. So if we already have RBAC, that we are able to create rules that have a subject, a Kubernetes API resource, and a verb. For example, we can code things like the user ARA for the kind pods. She can create, get, and watch those pods. If we already have that, why do we need something else? And the reason why we need something else is because RBAC, basically authorization, is a subset of all the policies that you may want to create on your Kubernetes cluster. To put examples of things that we can do with RBAC, rules like can I run an image coming from a third-party registry, or has my pod all the labels that are required by my organization. These are two very simple examples of things that you cannot code with RBAC itself. So you need to create policy that it's a little bit more complex than just RBAC rules. But you not only have to create them for your Kubernetes cluster, you probably have a full stack, technology stack in your systems that you need to create policy as well. So Open Policy Agent is an open source project by the CNCF as well, or OPA, it's called OPA, if you want to make it shorter. And it tries to create this engine for policy across many stacks. And it does that by decoupling policy decision with policy enforcement. How it does that? So for policy decision, basically what you're going to get is a query of something that basically, can I do this or I can't do this? And using that query and using policy that you have written in a specific domain language called Rego, and using some data that you may be storing in OPA, it returns a JSON with the decision, basically yes and no. So you get an input of JSON, very generic. You get an output also with JSON, fairly generic. So that's the only thing OPA does. It gets JSON in, it gives JSON out. So using that decision, how do you enforce the policy? How do you make that JSON into something that is enforced in your stack? And you do that by using any of the multiple integrations that are available for OPA. OPA is very successful for as a project, so there are many integrations. This is just an example. This is a screenshot of their website. If you go to the website, there are many more. And more being written every day. And this is where Gatekeeper goes in. Gatekeeper is one of these integrations for OPA that enforce decisions made by OPA into Kubernetes. And it does that by embedding OPA as a library inside the Gatekeeper controller. So you don't have to deploy two different things. By deploying Gatekeeper in your cluster, you're also deploying effectively an OPA engine. So how does enforce policy? So when you make a request to the Kubernetes API server, it goes through different phases. So it goes through authentication. Basically, is this request authenticated or not? If it is, it goes through authorization, basically RBAC. So can this user or service account can do this particular verb against this particular object? And if it's okay, it goes through a third phase, which is the admission controllers. And these are small pieces of code in the Kubernetes API server itself that do a little bit more. That's you can create more granular rules, but they have to be embedded into the binary that runs the Kubernetes API server. But there are two special ones, which are validating admission webhooks and mutating admission webhooks, that allows any external code to be part of those admission controller. And this is what the Gatekeeper controller implements. It implements a webhook. So when the API request goes through admission controllers, it will go through Gatekeeper and therefore the OPA engine to decide whether a request is valid or not based on the rules that you have created for your cluster. One of the great things, of the many great things that Gatekeeper has, is that it's very Kubernetes native. That means that it implements a lot of the design patterns that we see in Kubernetes over and over again, like extending the API, Kubernetes API with new objects through custom resource definitions that then the controller is going to manage for you. So in this famous reconciliation loop in Kubernetes. Two of the main objects that, kinds of the API that it creates are constraint templates and constraint. And basically constraint templates is reusable policy that you can instantiate into many as you want different constraints through parameters. To put an example of how this looks like, we are not going to explain in detail how to write Rego code, and we will see in the demo how you can reuse some of the things that are already there for you to start creating and using Gatekeeper in your cluster. But just to give you an idea, a template will have a little bit of Rego code, but also some parameters. And that it's not going to create any rules in your cluster by itself. So once you create those constraint templates in your cluster, nothing really happens. But then you can create instances of that template into rules. And the good thing about that is that once you have created a template, you can create as many rules as you want based on that template. So in this case, the required labels. We can create two very, very different rules. Like we can say all namespaces in our cluster require the Gatekeeper library. But we can also say things like all the parts in the default namespace require the do not delete label. And those two things are very different, but they come from exactly the same template. Which makes reuse of policy very, very simple. So one of the key design factors of Gatekeeper is making these rules repeatable and reusable over and over again. And the funny thing is that probably the rules that you already have in your head and you're thinking about applying to your cluster have been thought already by a lot of people before. They have similar things that they want to control, like things like images can only come from approved registries, or deployments required to have certain mandatory labels, or container images must have a digest, so you make sure that the code that you're deploying, you know exactly what it is. Or containers must have memory and CPU limits, and they have to be in a specific range. All these things are things that people are going to need in their cluster at some point. And for that, and because that's a key design factor of Gatekeeper, there is already a Gatekeeper library of reusable templates. So again, this is all open source, and you can go there and reuse the templates that all the people have written already. And those templates are very well tested. They are tested for every Gatekeeper release. So you make sure that they are going to be working over and over again. And to put an example of what these examples, this library has, for every piece of rule that they have a template. And this is the thing that you're going to apply to your cluster without modifying anything, if you don't want to modify anything. And it's great when you start because you don't know exactly how to write some rego, but you want to reuse some of these policies, so you can apply this template without modifying anything. And that's the thing that you're going to instantiate in your cluster over and over again. But the library also includes examples of how you can instantiate this particular rule, this particular template. And that allows you to have a better idea of how to do, to use that template. It's always better to see an example. So you will get examples of potential rules that you can create using that template, and also examples of objects that would fail that rule that it's on the constraint that you have here in the example. So with that, you can play and see quickly how to use that template, how to instantiate it, and what are the objects that would fail a potential rule. All of this, again, is open source, is part of the OPA organization in GitHub. So if you go there to that URL, you can not only deploy Gatekeeper, but also reuse all this library. Another great thing that I love about Gatekeeper is that it comes with very good out-of-the-box observability. So it has a bunch of out-of-the-box metrics that can help you as a Kubernetes administrator understand what's going on your Gatekeeper deployment, like the number of violations that you have, or the number of requests that are being made to the webhook, etc., etc. And if you are a Datadog user, you can use the out-of-the-box integration that we have that present all this information in a very easy way to digest with a dashboard, also with the logs, and we will see that in the demo as well. So let's start by looking a little bit to the demo. So we have here a cluster that I have created for this particular demo. It has just one single node. This is Minikube, so pretty simple. And we have Datadog already running. So Datadog is already running here. That's the only thing that it's running on my cluster. And the first thing that I'm going to do is to deploy Gatekeeper. And deploy, as you can see, deploying Gatekeeper, this is the full deployment that comes in their website. I haven't modified anything. So it creates a bunch of custom resource definitions and some deployments. So if we now get this namespace that it creates for you as well, if we see the pods that it has created, you can see that it has here the controller manager. This is the most important thing. This is the thing that is going to enforce those rules in your cluster. And you can see that we have 3 replicas of this controller manager. By default, Gatekeeper suggests you to run the controller manager in high availability. The reason is because if one of the replicas goes down and you only have one, then everything goes in, like it doesn't block anything. By default, obviously if the controller manager is not running, it's going to allow anything. But we also have another pod called audit, and this is also an important one that we are going to be seeing later on in the demo. So let's start by doing this. So again, part of the goal of this demo is showing you how easy it is to start with Gatekeeper without not knowing much about Rego yet. So what we are going to do is we are going to reuse the Gatekeeper library to create our own rules. So first thing we are going to do is to copy one of these rules, the required labels one, into our folder so we can modify it, and we are going to see what we get here. So again, the first thing that we get is a template, and this is the thing that you are going to apply without modifying to your cluster. But you can see that it's going to create a new object called required labels, and it has a bunch of arguments that we are going to use, and obviously the Rego code that, again, we are not going to go very deep into this demo today. So the first thing that we need to do is to apply the template. That's the first thing that we have to do. So we have created that template. The next thing that we need to do is to start creating rules. Again, by creating a template doesn't create a rule. So we are going to see the examples that it comes with. It has with this example that we are going to modify. Instead of, basically it says that all namespaces must have an owner label with a set of values. So instead of that, we are going to say all must have ContainerDays, for example. And instead of namespaces, we are going to say pods. And this is the message that the user trying to create a pod is going to get if they fail. So we are going to improve the message with the thing that we want to do. All pods require ContainerDays label, and we are going to allow any value. So because we are going to allow any value, we are going to remove all of this. That's the only thing that we require. We change the key of the label, obviously. We'll say ContainerDays. And basically we remove this because we allow any value. So that's the thing that we are going to do. So let's create that one. So we have created this new object, all must have ContainerDays. Cool. Another thing that I want to show you before we see how this rule works is that as soon as I deployed Gatekeeper in my system, the Datadog agent started collecting information without date. Basically, auto discovers that I run Gatekeeper in my cluster, and it's going to start collecting those that information. So let's see that. So if now I check my Datadog pod and I ask for its status, so we can see that we have here the Gatekeeper check running and collecting information from the audit pod, from the controller manager pods. All that data is going back directly to my Datadog account. So going back, we have created that rule of all pods must have that particular label. So if we try to create this pod, for example, an Nginx pod, very simple, it already has a label, run, but it's not the label that we want. So what happens if we try to apply that? It's going to fail. It's going to fail, and it's going to give me, as a user, message that I can use to fix my object. In this case, it says all pods must have a ContainerDays label that I don't have. So I know exactly what I need to do to fix it. So let's add the label. We said that the value of that label doesn't matter, so let's just put hey, for example. And now if we rerun this, it's going to be created successfully. So you can see that very easily using the library, we were able to modify the samples to create our own rules that are important to us, try to create an object that failed that rule, and basically fix that object so it was passing that rule. Okay, so remember that when we were saying the pods on the Gatekeeper system namespace, we were saying this audit pod, what that's for, what it's going to give us. So we are requiring all pods to have this new label, ContainerDays, but we had already a bunch of pods in our cluster that didn't have that rule, didn't have that label. So what happens to those? So obviously we cannot, every time that we create a new rule for a cluster, we cannot just remove everything that fails, because it would be basically breaking everything in the cluster is already running. But we want to know what are the objects that are failing a particular rule, so we can start fixing them on our own time. So if we get the list of rules, we have the required labels one here. So if you describe that one, it's going to give you all the objects that are already failing this one. In this case, kind pod, the reason why it's failing, but it doesn't stop that particular container, that particular pod, because it basically would be very disruptive. But you know, as an admin, what to fix or what to tell your users to fix. And this is also, you can see this in the Datadog dashboard. So if we open Datadog here and we go to the dashboard for Gatekeeper, we are going to be able to see that data in a visual form with the constraints that are happening in our system. So you know, you have a view of how your Gatekeeper system is behaving, the latency of webhooks, the logs of the container, the controller, in case you want to fix something, etc., etc. So as an admin, it's very useful to have all that data in one place. Good. So that was the first demo. But the second one, and I want to, the rule that we have created, like all pods require a certain set of labels, to decide, OPA to decide whether a particular pod that we're trying to create passed that rule or not. The only thing that it needs is the description of that pod. It's the only thing. But what about this other type of rule? The host must be unique among all ingresses. So if you create an ingress object and you have the host name, only one ingress object can have that same host name. The definition of the object that you're going to create is not enough to make a decision. And this is where the data that we were saying that OPA can use to make decisions comes into play. So you can not only use policy and the query, but also some data that you have stored. In this case, for this particular rule, we will need all ingresses that we create to have to be part of that data. How do we do that in Gatekeeper? Again, super Kubernetes friendly, very, very easy. You create this new type of object called config, specifying what are the objects that you want to make sure that are part of that data that OPA can use to make those decisions. So let's see another demo of that one. So if we go here to the Gatekeeper library again, in this case we are not going to modify anything, so we are going just to use the one that we have, unique ingress host. You can see that, as we saw, we have the template. That's the thing that we are going to apply. We can obviously have a look and see what it does, but let's, for the sake of this, just apply it. So we already have that template in. But it comes with something else that we hadn't seen before, which is the sync YAML definition. So this is basically what you need to apply for this particular rule for OPA to know what to sync for that data, what you're going to need for this particular. In this case, obviously, for any ingress object that we are going to create, we need to store them in that small database that OPA has to make decisions. So again, the only thing we need to do is to apply that object. And let's see one of the examples that it comes with. So as an example, it has the constraint that we have to create, and let's apply that one. So we already have a rule. Remember, the template doesn't create a rule, it's the instantiation of that template what creates the rule. And now, as everything on the Gatekeeper library comes with examples that has the constraint instance and the examples of objects that are going to fail. So let's have a look to this particular one. So as you can see, it's going to try to create two ingress objects. It's going to create the first one with this host, just an example, obviously, but then it's going to try to create a second one, different one, with the same host. And what is going to happen is that this first one, because it's the first time that Gatekeeper and OPA sees this host, is going to be approved. But as soon as it tries to create the second one, and because of that, because I have told Gatekeeper to store all ingresses that I create, it's going to fail this second one. So let's try that one. So you can see here two things. The first one was created successfully. It was the first time that I saw that host in my cluster, so everything was good. But as soon as I created it, it would sync very automatically into OPA, and then the second one would fail because it says that it already has a host with the same host name. It already has an ingress with the same host name. So that way you can see very easily where the Gatekeeper library has everything you need to apply those rules, not only the templates, not only the example, but also any config object that you need to create to sync the objects that are interesting. Cool. So that's all I had for today. I hope you learned something. I hope you use Gatekeeper. It's a great project. And I hope you have a great rest of the ContainerDays conference. Thanks a lot. And I hope to, again, if you want to reach out. Any questions, I'll be happy to help. Thank you. Bye.